electrical power. So what I've got set up here, I will quickly go through from your right to left. Power supply set for 12 volts, ammeter to measure the current through this lamp, a joule meter which will measure the energy per second output of this lamp, stop clock and a voltmeter. So switching these on, you can see current of 2.05 amperes, voltage 10.9 volts, and a display of the continual transfer of electrical energy into light energy from the lamp. Now obviously the lamp doesn't convert all the electrical energy into light. A vast amount of it is heat as well, but this is giving you the energy output in total from the lamp. Now what I'm going to do is to introduce you to the new power formula for electrical energy. I'm going to take a note of, you should remember from previous that we've already looked that power is joules per second. So in other words, 1 watt is 1 joule per second. So what I'm going to do is I'm going to measure the number of joules released from this lamp in 20 seconds. So I need to reset and start the stop clock. So reset, hold it, and 3, 2, 1, go. Stop clock's going, joule meter's going. I'll switch the lamp off, it's easiest that way when it hits 20 seconds. And take a note of the readings. 18, 19, 20. Not the most accurate, but I'll take that. Time of 20 gave us an energy of 399 joules seconds. Now also, because this is leading to a relationship we've used before, I've also put an ammeter and a voltmeter in the circuit. Now the reason being is to try and relate or show that there are other ways to work out electrical energy and electrical power, not necessarily using joules for example, but using current and voltage. So for here I've got, what's that, 11.2 and 2.0. So I've got a current of say 2 amperes and a voltage of 11 point, it's fluctuating. I'm going to stick with 2. Now, switching these off, is try to show you that in the past, the formula we've used, that power was energy over time, the electrical energy that was released was 399 in a time of 20 seconds, and that's as good as 20 watts. I'm happy enough with that. Let's stick it in there. 399, 20. So that's as good as 20 watts. The current and voltage, 2 amperes, 11.2 volts. 2 amperes, 11.2 volts. Now, new relationship. Now, if you multiply the current by the voltage, you will also have the power. Now, what would happen in an ideal world is that these two would be the same. Now, they're not. You could put it down to the accuracies of all the measuring devices. The 2 meters, the joule meter, even the stop clock itself. But in an ideal world, the electrical energy divided by the time to give you the electrical power of the lamp is the same as the current through the lamp multiplied by the voltage across the lamp to give you also the power.